Today we're working on notes 2.5, solving and graphing quadratic equations. So when we solve a quadratic equation, we usually want to choose the method based off of the form of the equation. So if it's in what we call standard form, which looks like this, we're going to try to factor it to solve. If the quadratic isn't again in standard form and cannot be factored, we're going to use the quadratic formula. If it's in what we call descriptive or vertex form, which is what we have here, then we want to solve with square roots. So when you look at the problem, you want to make sure you understand what's standard form, what is vertex form. Right? Standard form is going to have the three terms. Vertex form is going to have that set of parentheses in it. Now the quadratic formula, a negative b plus or minus the square root of b squared minus 4ac all over 2a. So this will give you the values that make your solution equal to 0 for any quadratic formula, as long as you have it in standard form. As long as you know what a is, b is, and c is. Now sometimes when you're solving quadratics, right, you can get what we call imaginary solutions. So there's no longer no solution. It's not an option now. We can have imaginary solutions. So we denote the imaginary numbers with the symbol I. I represents the square root of negative 1. So that's really probably the most you're going to really need to know for this, is I is square root of negative 1. But for those of you that go on to other classes, you could see this again. So if you were to square that, right, you'd have negative 1. If you were to cube it, you'd have negative I. And if you raise it to the fourth power, you'd have 1. But this is the main thing. So when we get to a negative underneath our radical, we don't get to just write no real solution anymore. We need to figure out the actual imaginary solutions. So looking at example 1, right, that's in standard form. Right, we have x squared minus 6x plus 8 equals 0. So we're going to try to factor it. If we can't factor it, then we would do the quadratic formula. So if it does factor, right, it's going to factor into two binomials. The only way to get x squared is x times x. So I need the factors of 8 that add up to 6. So that would be 2 and 4. So 2 and 4. It's got to be a negative 6, so minus and minus. So this is what we did in our last lesson. So now I set each one of these to equal to 0, each factor, because one of them has to be 0. Add 2 to both sides here, add 4 to both sides here, and now you have your two solutions. And remember, you're solving a quadratic. So most of the time, you're going to end up with two solutions. So keep that in mind. Now, if you go to the next example, right, this looks like it's going to be in standard form. So we're going to set it equal to 0 by subtracting 18, right, from both sides. So now, right, it is a quadratic, and we can try to factor if we want. So if we does factor, again, it'll be two binomials. Good thing is 3 is prime, so 3x and x. So now factors of 18, 1 and 18, 2 and 9, 3 and 6. Now, the GCF for 3, 25, and 18, because we want to keep remembering that because we're trying to factor it, is 1. So that's going to eliminate some of my choices. So for example, I know I can't use 3 and 6 because then I'd have a GCF other than 1. So we can try 2 and 9. So 2x, 27. Can I make 27 and 2 become 25? Yes, I can. If this is positive and this was minus, that would give me positive 25. So minus plus. So this one I was able to factor. So now Keeping that in mind, I'm going to set each factor equal to 0, and then I'm going to solve the linear equation. So add 2 to both sides, divide by 3, so 2/3, subtract 9, so -9. So I get my two solutions. So both of those were basically based off of like what we went over in the last section. We were able to factor and solve. Now that's not always going to be the case. So example 2 kind of looks like example 1, the second one. So I'm going to subtract the 4 over. All right, I'm going to minus 4. So we have 2x squared minus 6x plus 1. So if you tried to factor this, you couldn't factor this with nice whole numbers. You could sit here and try to figure out fractions and stuff, but it won't factor with nice whole numbers. So we're going to have to do the quadratic formula. So this is my A, my B, my C. So again, using the quadratic formula, which is right here. So minus B, so minus a minus 6, plus or minus 4 times A. Oh, whoops, geez, getting ahead of myself. Got to remember to square B. Minus 4 times A times C, all over 2A. And notice as I enter the values, I enter them with grouping symbols. So I make sure I remember the sign. Because the step I just did in red is where most students make the mistake. It's because they mess up the signs. That's the number one mistake, is literally just plugging the numbers in. Something you've been doing since junior high. Next, you got to be careful with your signs, and we just start simplifying. Right? Out front, that becomes a positive 6. This becomes 36 minus 8. All over 4. And now we're just simplifying. Right? 6 plus or minus the square root. 36 minus 8 is 28. And now you simplify. 28 is 4 and 7. So it's 6 plus or minus 2 root 7 over 4. That should look familiar. We did a few of those problems in our last lesson. Right in the back side of the notes. So I do notice that 6, 2, and 4 are all divisible by 2. So I'm going to divide them by 2 to simplify. So I'm dividing by 2. And now I get my simplified answer. But that only works when all three of those numbers are divisible by the same number. Sometimes they're not. In this case, they were all even, so I could divide all of them by 2. So what I circled down there in purple is your answer. And there are two answers there. There's a plus and a minus. But that you don't need to go any further. So when you're solving with the quadratic formula, you're often going to get answers that aren't very pretty. They're not going to be nice whole numbers. They're going to often involve radicals. Sometimes they involve imaginary numbers. Okay, next one. Same idea. You could try to factor it, but there's no multiples of 6 that give you 4. There's no nice whole numbers that multiply to give you 6 and add to give you 4. So, going to use the quadratic formula. A is 1, B is 4, C is 6. So minus 4 plus or minus 4 squared minus 4 times A times C all over 2A. And again, make sure you double check your signs. Make sure you put the correct A, B, and C value, because sometimes they could be rearranged. A is the term in front of the squared. B is the term from x to the first power. C is the constant. And now you start to simplify. So negative 4 plus or minus 16 minus 24 over 2. Negative 4 plus or minus the square root So 16 minus 24 is going to give me a negative. So as soon as I see negative, I know I'm going to get imaginary solutions. So 16 minus 24 is negative 8. So I don't get to say no real solution. There are solutions. They're imaginary. So we're going to simplify the 8. So 8 is 4 and 2. So it's 2 root 2. So this becomes negative 4 plus or minus. Now I got to take care of the negative. Well, that's what the I is for. So 2i root 2 over 2. So the 2 root 2 is here. The I takes care of the negative. So again, the I takes care of negatives. Because basically what's happening, it's root 8 times root negative 1. So it's root 8 times I. Right? Because I is the root negative 1. And now, just like we did last time, I notice that 4, the 2, and the 2 can all be divided by 2. So there we go. And you don't have to write the 1 on the bottom. You could just write negative 2 plus or minus I root 2. So 4 perfect examples. 2 you could factor. 1 that came out to a square root, and 1 that was imaginary. So this is what you can happen on these problems. You can get ones you can factor and ones you cannot. All right, go ahead and flip your notes over. Now, first thing that hopefully jumps out to you is looking at example 3. All 3 of those are different than the 4 problems we just did. Why? Why are they different? Well, hopefully you realize that they have the grouping symbols, the parentheses with the square. That to me, like, just jumps off the page at me. So hopefully you're seeing that. So these 3, I'm going to solve differently than the last 4. So all 3 of these, I'm going to get the square part by itself. I'm going to isolate it. And then I'm going to use square roots. So I'm going to add 5 to both sides. So now I can square root both sides. So you get x plus 4. But remember, when we're solving an equation and we're using square roots, we get the plus and the minus. Root 11 can't be simplified. Right? 11 is prime. There's nothing we can do to break it down. So we can subtract 4. So there you go. So if you were to go any further, you would get decimal answers. So we will stop there. Okay, next example, same idea. I'm going to subtract 4. Okay, now I'm going to square root both sides. Uh-oh. I'm taking the square root of a negative. So that tells me right now I'm going to get imaginary solutions. So I is going to come into play. But it's the same thing. The I just takes care of that negative underneath the radical. So this is still going to be plus or minus. The square root of 4 is 2. So this is plus or minus 2i. Again, the I takes care of that negative. Now I'm going to add 1 to both sides. So 1 plus or minus 2i. So that would be your final answer. So anytime you end up with an I or a radical you can't simplify, you don't have to go any further. You can stop with the plus or minus there. Okay, the last example here. We're going to add 2 to both sides. Okay, but again, I want to get this isolated. So I'm going to multiply by the reciprocal of 1/2, which is 2 over 1. And I'm going to do it to both sides. So these just reduce on the left. And then we get 4 on the right. So now I can square root both sides. So the left is x minus 2. On the right, it's plus or minus 2. Right? The square root of 4 Remember, we're solving the equation, so we have the plus and the minus. So it's 2 squared is 4 and negative 2 squared is 4. Add 2 over. Now, before the last two examples, we were able to stop. But now I have whole numbers, so I can get a more precise answer. So I'm going to go further. So 2 plus 2 is 4. 2 minus 2 is 0. So there are my two answers. The last two examples, I couldn't go any further because I have a radical and imaginary. It's not going to help me. Here I can go further because I have nice whole numbers. So those three we solved with square roots because they had their grouping symbols. They were in what we call vertex form. So now what we're going to do is we're going to solve it algebraically. Okay, so we're going to graph the quadratic and a line and figure out where they intersect. Those are going to be my solutions. So first one here, we have two functions. We have a quadratic and we have a line. So I'm going to graph the quadratic in the blue. So its vertex has been shifted to the right 1 and up 4. Okay, so now it's a 1. So right, remember we can use our pattern 1A, 3A, 5A. A is 1, so 1, 3, 5. Over 1, up 1. Left 1, up 1. And you could go up 3, but it goes off. Okay. Now we're going to do our linear function, which is a line at 0. So there we go. There's g of x. This was f of x. So it says where are they equal. So when I ask you where are two functions equal, graphically that means where do they intersect? Well, they don't intersect anywhere. Right? So they don't have a solution. So that means algebraically when I go to solve this, I shouldn't get a solution. So that means I'm probably going to get imaginary solutions. Because there shouldn't be a real solution, because if there was a real solution, the blue and the green graph would intersect, and they don't. So we're going to solve it algebraically and make sure we get that correct answer. So f of x equals g of x. So subtract 4. Oh, look at that. That's just like the one straight above, right? It's just like this one up here. Right, you square root both sides, you're going to end up getting x equals 1 plus or minus 2i. Like we said it should. There should be no real solution. This has no real solution. So when you're solving these quadratics, you're really figuring out where does the graph cross the x-axis. So when you set your equations equal to 0, you're actually finding the x-intercepts. So when I see this quadratic and we set equal to 0 and there was no solution, that tells me there's no x-intercepts. But we'll get to that down the road. So please make sure you answer your essential question up top. And then as you're